See, everybody look up, everybody. Listen, I want to just quickly show you something before we start. Please, can you shut down the distraction? Please clean that up. Shut down all that. Now look up to the screen. Look up to the screen. See, look at the Windows button. When you press it like this, you have not started here. You've not started, but I just want to demonstrate something to you. We want to confirm if Java is existing in the system. If Java is installed. So you come to this menu, then you type terminal. You can just do that like now. Then we move down to this, you run it as administrator, and it's going to give you a prompt. Make sure you click yes. Now this comes out. As you can see on the screen, this is the program. Now, when you get to this program, please can you be quiet? When you get to this place, then you now type JAVAC and you press enter. What's it bringing up? What's it bringing up? It should give you something like yes. The reason why it's giving this is simply because Java is not installed. Okay, for the command prompt, this is a Windows platform. So just put that aside. We've not started. I just want to show you this because right now I'm going to copy the files for Java. I'm going to copy this flash and then someone is going to go around and drop it to the systems so we can install it. Can you do this back? So we are on. All right, so welcome everybody, and as you all know, this is a coding class, weekend coding class, and the objectives, one of the major objectives of what we are doing is embedded in giving you skills, not just to pass your exams, but skills you can use for a very long time, for a lifetime. It's not just for you to prepare for an exam, but it's also for you to be useful, for it to be useful in the productive, in the productive aspect or category of your life. So today we're going to be looking at computers, what they are, the hardware, and then we are focusing more on the software because this is a coding class, and the importance of you knowing the fundamentals of what programs are cannot be emphasized. Who can tell us what is a software? What do you understand by software? What is software? What do you understand by software or coding per se? What is coding? Anyone? Speak up.
Software is the inner part of
the inner part? No. It's not the inner part. Anybody here? Yes? Okay. Now I want you to pay attention to this. These are part of things you know. You guys you all have ideas of what software coding is. Alright? So that's why I need you to pay attention. And if you have your biro and paper, ensure you write down these key points as we progress. Now, as you can see on the screen, it's telling us here that this is an electronic device. That's a computer. It's an electronic device operating under the control of instructions stored in its own memory that can 1. Accept data, 2. Process the data, 3. Produce results, 4. Store the results storage for future use. If you are asked, whether you are asked formally or informally, This is how you are expected to give an answer to what a computer is. And you don't need to, memorize everything. The most important thing is you say it's an electronic device. Alright? It has instructions, okay, has its own memory, and then has these functions: accepting data, processing data, producing results, and storing the results for future use. That's all. It's not hard for you to have this behind your mind. So anytime you ask what a computer is, this is exactly what you're supposed to give as the right answer. Now, we move on to what really is a computer. These are few examples of what we know as a computer. Of course, we all know what's this? That's a printer. Then that's the next one. What is it? Huh? You are not sure. See, this one is doing one like this. What is this? The second one? Huh? Someone is saying scanner. What is it? What is this? On the screen there, that one in the middle. Huh? Yes. What is the system unit? Some of you mistakenly call it CPU. It's not CPU. CPU is only part of that system unit, which you can see here. And you're seeing alongside this lab. So this is system unit, system box. The next one is what? What kind of monitor is that? What kind of monitor is it? That is just theoretical thing you're saying. This thing has a name. That thing you're saying, it has a name. What's the name? That is, right. That's an liquid crystal display monitor. LCD. Write it down. That is an LCD. It succeeded the CRT. We should talk about the CRT. LCD, liquid crystal display. That's it. There. Then beside you can see a keyboard and a mouse and speakers. There are speakers there. We're done with that. The next one is what? Well, then the next one, USB flash drive. That's a whiteboard. Then what else do we have here? We have what? What's this? Memory card. You can see that. Then this one is what? External hard disk. Let me give you a very, very typical instance of what that is. This is it. These are the external hard disk. What is it used for? Storage. For what? Storage. To store it in. What is this thing used for? Eh? I'm not hearing anything. They are not even sure. To what? It stores data, external data. You can use it for backups. Don't forget, please, in case of next time. Then the last one there is what? A modem, like what you're seeing here. Like this MTM, this is what is a modem. So let's keep it going. Now, yeah, these are examples of computers. You can see desktop, PDAs, tablets, mainframes, smartphone. Some of these things you see every day. But it's a pity that some of us don't even know what they are. We see them every day, but we don't know the name. So, as you have been sent to school now, you will be the educated guest on the street. Somebody who is doing in the streets of Lagos, walking and saying any kind of thing, all kinds of things. You will come and say, this is what it is. So you can stand out of the crowd. You say, that this is an educated man, this is an educated woman. So the right names for these things are very, very important. Now, I'm going to send this thing to a copy of this thing to this house so you can get a copy. Or if you have an email, drop your email and I can send it to you directly. So you can read that. Now, computer system is only functional if there is hardware, there are users, and there are software. Now, basic hardware components. Can you all read this? 1, 2, go, and from the beginning. And then the other one. Speak up. Good. Now, you can see some of the devices there, because these are things that many of you are already familiar with. Now, hardware components, you can see the system box, that's the power supply, that's CPU. The CPU is a component, like I said. CPU is always a component of the system box or the system unit. Alright? There's a lot of things embedded in that box. Now, here you have the motherboard, you have the RAM, then of course you have the NIC. What's the meaning of NIC? You can tell me. Very good. Network interface. I don't want anybody moving around because of this camera. I want everybody to be in a place. Don't be moving back and forth. So you will not, the frames are capturing. So any movement you did, it's going to record, it's recording it. I need you to be steady in place. So let's move on. These are some of the other hardware components we have. You can see the physical, the hardware, the hard disk itself. Shay, is there a problem? No, sir. Can you just be still? Yes, sir. The memory, the hard disk. You can see that's another set of hard disks there. And these hard disks, they have categories. You have the SATA drive, and then you have the ID. Alright? But that's not for today. We're not going to cover that today. Just for you to know the peripherals of the system is very important as a foundation for learning coding programs. Now here you can see some other peripherals there, the mouse, keyboard, the sound speaker, the webcam, and scanner. Then here, these are serial ports. You know, some of these serial ports are no longer in use. Like this PS2 there. PS2, those groundish things. The new generation of computers don't use these things again. What they use now is they use USB, which is more digital. These ones are almost become analog, with the exception of the HDMI. Like this projector now, I'm using the HDMI to connect from it to the computer. This computer now is a new generation. It's fairly a new generation computer because it doesn't have these ports. This one here. This one. What's the name of this port? Who knows it? Who can tell us? Okay, so like we're saying, look at now the relationship between hardware and software. Hardware and software are mutually dependent on each other. Both of them must work together to make a computer produce output. So they are mutually exclusive, they work together, hardware and software. Now, software cannot be utilized without supporting hardware. A hardware without set of programs to operate one cannot be utilized, and it is useless. To get particular job done on the computer, relevant software should be loaded into the hardware. For instance, a device driver is needed. Now, a device driver is a program that controls a particular type of device that is attached to your computer. There are device drivers for printers, displays, CD-ROMs, CD disks, diskettes, etc. Hardware is a one-time expense. Now, let's look at the relation between hardware and software before we are still continuing with that. Software development is very expensive and is a continuing expense. Different software applications can be loaded on the hardware to run different jobs. A software acts as an interface between user and hardware. If hardware is the heart of the computer system, software is the soul of the computer. Now, let me look at that. Look, everybody look up, please focus on. Now, you can see some of, I listed these as some of the coding languages and applications for your knowledge that you need to be familiar with. Number one, you can see the logo there. What's in that? Everybody read it down. 1, 2, go. And then the application is what? Good. Then number 2, this is PHP SQL. What is this used for? This is the description. Read the description here. PHP SQL Apache. And then the application is what? Web development. Good. Number 3. For native web apps and game apps, there are different things. Native, anytime you say you hear of native software, it means a software that is offline. You should write that down. You are recording this, you're going to have a recording session. Alright? I'm recording it from 2 sections, from 2 areas, from there and from here. So you can play back the video when you get it. So we are where? What number are we here? Are we done? Okay, I was explaining 3. The native. Anytime you hear about the native, a native software is an offline software that does not require internet connectivity. While a web application or a web software is a software that is based online. You cannot use it without internet. Alright? Examples of native software are, of course, Microsoft, you can use the full functionality without internet. The internet is an option. Current one, you can use, but though these days, a lot of them come along with the components of an online component. And that brings us to the third category of software programs. Hybrid. A hybrid software is a software, the kind of software that can operate online and offline. So it combines the features of the native and the web apps together. And that's what most of these softwares are becoming these days. Facebook is you cannot use it online, you cannot use it offline, you can only use it online, so it's a web application. Twitter, Tinder, and TikTok, these are all appearing you cannot use offline. Can you use it offline? You have to have that. So anything that you have to use data, you have to load MTN, Glo, Line Mobile, or any of the likes is a web application. Anything that you can operate on your computer, on your phone, or your computer without internet connectivity is what? A native software application. A native software application. A web-based software application can only be used online, while a native-based software application can what? Good. So that is that. And that's why that number 3 comes in very handy. Now let's go to number 4. Can anybody read out number 4? The description there was there. Want to go? Kotlin, Java. Now, in the beginning, when Android phones started, we were using Java. But now the language the Android phones is using is called Kotlin. It was produced by Google. It just works like Java, when you say. Now, what's the application? Can anybody read it out there? What's the application there?
For mobile apps.
For mobile apps. That's what number 4 does. Then number 5. Good. That's a no good. Yeah, what is it used for?
Game.
Good. Then the last one there. And then what's the function there? Good. Now let's quickly look at this. Now this aspect is something I need you to focus on. It's very, very important. Object-oriented concept of coding software. Now every program there's something that we call objects and classes in coding. Now I want you to write down something. An object is the instance of a class. Write that down. An object is the instance of a class. An object is the instance of a class. Now, what this means is, look up, if you are reading that, what it means is that you, if you're a daughter, you are the instance of your mother. If you're a dad, you are the instance of your what? Father. So the father is the class and you are the what? Object. The mother is the class and you are the what? You don't have the object. Then you can also have parents as a class and children as the object. An object is the instance of a class. What is your name? What's your Nigerian name? You don't have one. You don't have Chiwe or Chima. Who has an African name here? Nigerian name. Who has an African name here?
There are many now. Chidebere.
You are free to call your African name. Chidebere. Now, like Chidebere now, Chidebere and the sisters or brothers are the instance of their what? Parents. So that's just the general concept of objects and classes. Now, I'm going to show you something here now. Like you can see here, I did try to make a description here, but it's not that elaborate. But this one gives no elaboration. As you can see now, object-oriented programming. You can see the class as human. For this example, now you have the class as human, then you have the object as name. So the name is the instance of the words. Good. The name is the instance of the what? Human. The name is the instance of the human. So then, apart from that, now I want to also give you this analogy. An object is the instance of the class. We already established that fact. Now, the next thing you need to know is that for every object or class, there is a property. You can also say an object is a noun. What is a noun? Who knows what a noun is? Name of a person, animal, place, or what? So, an object or class is a noun. While the property of that class, like your ear now, this ear, yes, no, this ear now is the property of the Chidebere. Chidebere has his ear as a property. His nose is his property, his mouth is his property. It's nobody's property, it is his property. So he's responsible for it. And it's also called, what do you call an adjective in English? What does an adjective do? It describes a noun, right? Good. So I can describe Chidebere with his ears, with his face, with his nose. Those are features that describe him, adjectives. And that brings us to these properties. Every object and class has a word property. Every class has a what? Property, as well as an object. So since the object inherits everything that the class is, then that means it also has its own properties. Now let's look at this, the last one here, the methods. Now, what do we use ear for? Is it not for hearing? Yes. What is hearing in English? Is it verb, adverb, or verb? And what does a verb do? A verb does what?
It's an action word.
It's an action word. So methods are verbs. They perform what? Action in coding or programming languages. Is that understood?
Yes.
What's your own name? Give me. I go by African names. Olufemi. Olufemi has legs that can walk. Her leg is her property, but the action that leg does is what? Walking. So she walks. Okay, so now here is another concept of the object-oriented. Say all concepts, look up everybody, all concepts of object-oriented programming are the same in all coding languages like Java, Python, PHP, Kotlin, or Android. Now, look at this is a typical example. Now, everybody look up, this is very important. This is Java. Look at the way they define the class. This class is called what? Hello World. What is it? Everybody say it. Class what? Now, you have public. I'm going to explain this thing as in time, as we progress. Public, when you make something public in programming, in coding, it means you are making it public, you are making it global, accessible to everything. That's what it means. Public. Static. Static means it is just performing a function. And the name of that static void is main. The main function. See, the color is different. This is the main function. This one are reserved words, public static void. You can see the color indicators are the same. This is the name of the function. Now, these are strings that you supply during the execution of the program. I'm going to come to this is theory. When we start the practical, you get to see. Now, here you see an object, property, and method. Please pay close attention. This is Java. Object, property, method. Object, system, out. Function is what? Our method is what? Print line. This thing now is part of the Java program. It's a class called system. Okay? The system calls its property out and then calls a function called what? Print line. This thing you're seeing means print line hello world. The braces you are seeing here is the starting and ending for the function. This one is the starting and ending for the class itself. I want to go over this video. When you go over it, you understand it as time goes on. Let me give you another example. Now, this is C++. The object-oriented function. Now, this is a typical coding This is typical coding. Now pay attention, pay very close attention. Who is talking there? Who's talking there? I don't want anybody to be distracted. Now, this is a typical class program for C++. You have int main. Main is the main function being called. std count, hello world. This std count is saying output. This is an object in C++ calling a function saying std count. Now let me explain to you in clear terms. What did you call your name again? Olufemi is a lady. She can call any of our functions. If she wants to listen to Chidebere, she will listen to him, Abi. If she doesn't want to, she has the authority to disconnect, right? Good. Now, let's come back to this. This is a C++ class. This std is an object. And it's calling what? Its function. Output. Output, hello world. Because it belongs to it. Just like Opeyemi has her ear, she can block it and she can close her eyes, she can open it. She can call any of her functions as an object or as a class. Is that understood? So that is how this works. This is a function on its own that is called main. Now in that function you have another object that is calling, or a class that is calling its function. And the function here is what is output. Say std output. This class now belongs to the C++, one of the libraries. Okay, let me explain to you. You know what is Bodmans? Can anybody know what Bodmans is? What's Bodmans? Brackets. Assuming I wanted to create a class of Bodmans, I can create a class of brackets with a function of multiplication or addition, right? Or subtraction. I want you to understand the concept of objects, because if you understand it now, you understand it for good, and you don't need to go back and forth in understanding how to write coding programs. This is very, very important. Now let's leave this and go here. This is C#. This is Microsoft proprietary. This is how to write a hello world in C++. You can see it declares a namespace. That namespace is like an encapsulator. It encapsulates, like it holds everything together. The public class, the class is, of course, like I explained today, the class is like a parent. Now the name of the class is program. Now it has static void, just like Java too. Void means string adds. These ones are just the way of declaring the function in C#. Now you have the main as the name of the function. You have arguments that you supply, string arguments, optional that you can supply. Then you have console, right line, you know, that's the console is like the class or object that is calling the function right line. Like I explained before, Ope can call an hearing. So console is the class and it's calling right line hello world. The end of it is still calling console again. Console is calling another function called read key. Just like what Chidebere can do. Chidebere as an object can call his ear to ear, eyes to see. If he wants to see, you carry his eyes and he will see. If he wants to walk, you see this and move. So the same thing applies to this. Then finally you have the Kotlin. This is Kotlin. You can see the structure of it is the same. Now I'm not going to go deep into this one. What you can see here is the class. Then you can see super on create, set control, super on create, save instance state. Super on its own is a class calling a function called on create. Set content view is a function that is calling this argument. This is the first time you are seeing this kind of codes, but I believe with time you are going to understand them. Alright? Object-oriented programming in Python. Now this is Python. You have class greeter. This is how to define function in Python. Greeter is calling this, see, is initializing. This is an example of initialization. Object is an instance of a class. Greeter. This is not the same as this. So, you know this one is lowercase. This is uppercase. So when you get into programming, when you are writing this kind of things, you should know that this is not the same as this. This is the object, this is the class. Look at this is the class. Is it not the same thing there?
Yes.
Are they not the same spelling?
Yes.
This is the class, you see. So this is the object. See, an object is the instance of a class. Chidebere is the instance of his father. This is the father now. This is Chidebere. Chidebere is calling what? The father. Call what? Greeter. Let's just assume that we are just, I want to bring it home. Opeyemi, Abi. Let's say this is Opeyemi. This is Opeyemi. Opeyemi is now, wherever she is, she's now going to call her father. Once this thing is done, this is what we call initialization. Once she calls this, everything belonging to our mom and her dad belongs to her. So here we now have the function and then the input. So that is that. Then for PHP, we are going to be doing that too. So for now, we're going to stop there. And the next thing we are going to do now is, yes. So everybody, open that folder. Open that folder.
Teaching hardware at the end. E.g. operating system, compiler, interpreter, assembler.
Good. I want everybody now to read that software in the definition, the first paragraph. 1, 2, go. You are not speaking coherently. Speak coherently. I want everybody to sing it like in unity. Don't be talking. Some of you are reading behind, some are before. 1, 2, go.
What is software? Software is a set of programs